here is my gain reduction circuit. What I'm trying to do is create a DC offset so that I can have this go to a 0 position. So I've randomly selected 16 as my 0. And right now what I'm doing is I'm putting 3.3 through a 22K through a 1K pot into the input of my circuit, which I'll show you in a second. And ultimately I can use that pot to simulate a DC value like it would be coming out of an RMS detector or peak to peak. So I can twiddle the pot and get the VU to swing. So this is pretty much full deflection. Now I'll hook it up for music and we'll see that. All right, so I've got Rolling Stones Miss You for my test music because it has some nice drum sounds. Unfortunately, you won't hear it, but I'm gonna play it. And you can see I've got my sensitivity set there. So this is supposed to be gain reduction. I crank it up. You get more signal, obviously, and the peaks and the valleys of the signal are being shown. I'll turn it down. So now it's no gain reduction. Crank it up again. See it come now, the circuit itself, albeit I'm not showing the RMS detector or the peak detector option here, but I am showing you essentially what I've done. I have a bias setting here, and that's simply to give a DC offset to the output that will drive the meter, and that's to get you to the VU 0 dBu, so that's 16 on my scale here. And then I put the DC signal, roughly DC signal, in through here, or the music signal for that matter. This resistor there is just to give me a little bit of finesse control if I want to control how hard it's hitting it current-wise. I then have this little transistor here, and so what I'm doing is I'm taking a DC level, and when the music starts up, it turns on this transistor and essentially shorts this down, so pulls this down, so your waveform goes up, it'll sharply down, and when the music stops, it'll release it and it'll come back up. So it's kind of like a noise gate, if you will. And then what that does is it drives that meter voltage down when the music's playing, so you can see gain reduction for your circuit. Now, and that just goes through a buffer into the output, and that's all we've got. The important thing is with this particular meter, and it varies between the meters, this resistor is 240K driving it. I am putting a sine wave into this thing, and again, it's sort of an arbitrary value that I'm putting in. It's a pretty hot value, it's 4 volts peak to peak I'm putting in, but just to show you the circuit. So the blue trace is the output, and you can see it driving it down. So that lower section, when it reaches past its threshold, starts to come down, holds it until the threshold turns back down lower. So it is only doing it on the positive cycle of the waveform. But keep in mind, before this, there's an RMS detector circuit that's taking the AC signal and converting it to RMS, and there's a peak detector option too, so you could go either way. So either way, it's being essentially rectified. So it will be a positive voltage coming in here. It's 5 volts on the blue trace and 100 millivolts on the yellow trace. So now if I were to drop the voltage on my little signal generator here, just select the 4 volts and I'll make it 1 volt peak to peak. So it's returned to its DC threshold. So let's go 3, boom. Now we're starting to see something happen. And again, all of these thresholds I can adjust.